Okay, today we're going to take a look at a different type of equation that we haven't solved yet, and that is called the quadratic equation. Now, one of the keys to recognizing that you have a quadratic equation is that it's in the form of, or can be written in the form of ax squared plus bx plus c, and be equal to some number, preferably 0, but we can adjust it if it's not. The key identifier here is that you have an x squared as the lead variable. It doesn't necessarily have to have a number in front of it. It can have just x squared there or anything else. But anytime you have a second degree equation or a second degree polynomial as the equation, that means that it's quadratic in nature. Another example of one might be something along the lines of 3x squared plus, I don't know, let's say 8x minus 2 equals 0. That would be a quadratic equation, and we would have to solve it a little bit differently than what we've learned so far. You can also stumble across what we call quadratic functions. A quadratic function is basically in the same form, but it's just got the f of x out here, just written a little bit differently than an equation, but we can still solve it and find what we call the zeros of that function, and we'll look at some of those today as well. When you graph a quadratic equation, you can see I've got a sketch of a graph over here. This is the equation f of x, or it's actually the function f of x equals x squared minus x minus 6. You can see that it graphs this funny looking U shape, which we refer to as a parabola. We'll look more at how we can use these graphs later on, but for right now we're just going to look at finding the solutions to some simpler quadratic equations. And before we get into that, we should recognize also that all quadratic equations are going to have two solutions and not just one, like the linear equations that we've been working with to this point. So we'll be looking for two solutions. In some cases we'll only find one, but we'll look at that special case scenario later on. But for the most part, all quadratic equations we can expect to have two solutions, or two values that would represent that x value that would work in the equation. So let's look at the methods we're going to actually use here to solve a quadratic equation. Let me get this going real quick. To solve, one method that we'll use is what we call factoring, and we've been working a lot on factoring lately. We'll be using those techniques to actually get the solutions to the quadratic equations that we're working with. And it's one method. There are several others that we'll take a look at as well. When we solve by factoring, we're going to first off make sure that we have all the values in the equation over on one side of the equal sign, and we should have 0 on the other. The equation is going to actually be set to be equal to 0, and that's kind of like the model that we saw earlier on the other screen. If it's not in that form, we can adjust it. We can move terms around and set it up that way. Once we get it equal to 0, we're going to factor the equation out and apply what we call the zero principle. Now, the zero principle is basically what we do is a technique that we'll use. Is based on the fact that anytime we multiply things together and they're equal to 0, then at least one of the terms in the multiplication problem should be equal to 0. So we're going to use that by setting each factor equal to 0 and solving for the variable at that time. So bear with me a little bit here. We're going to look at some examples here, and hopefully that'll clear up. But we call it the zero principle. All right, let's look at an example now. Say we've got the equation x squared plus 4x equals 12. Now you can see that this is a quadratic equation, first off because we have the x squared there, and that's usually a dead giveaway that we have a quadratic equation. Now, this one is not equal to 0, and that's the first thing that we want to do. We want to get everything on one side of the equation. So we're going to have to take this 12 here and move it over. Now, we would do that by subtracting 12 off of both sides and adjusting the equation in that manner. So we'll have x squared plus 4x minus 12 is equal to 0. Again, that's something that we should understand there, just algebraically manipulating the equation to set it up to the form we need. Now that we have this, x squared plus 4x minus 12 equals 0, we're going to take this and factor it out. We'll take the x squared plus 4x minus 12 equals 0. We can factor that. I'll pause here for a second, give you a second to think about it, but we should factor that using the trinomial methods that we've worked on before. And if you like, you can press the pause key and factor it out. Okay, and if you've got that, you're ahead of the game, but we're going to take this negative 12x squared, and we can multiply the first and last terms and get that, and then we're going to find factors of that would subtract to make 4. So we'll be using positive 6 and negative 2 in the middle here to replace the 4x and factor that out. We group now. Out of the first group, we can take an x squared, or excuse me, an x, and that would leave us with x times x minus 2. Out of the second group, we can take a 6, which would leave us with 6 times x minus 2. And of course, now we can see that that's going to factor into x minus 2 times x plus 6. And it's still equal to 0 like we had. Now that we've got this factored out, we're going to jump into using what we called the zero principle earlier, by setting each factor, x minus 2 and x plus 6, equal to 0. So we say x minus 2 equals 0, and that of course would be solved by getting x equals 2. Then we would set the other factor, x plus 6, equal to 0, and to solve that for x, we would subtract 6 over, and we would get x equals negative 6. So we have the solutions, our two solutions, would be x is equal to 2 or negative 6. Again, we should expect two solutions anytime we have a quadratic equation. Let's look at another example here, kind of hammering home the point. 2x squared plus 14 equals negative 11x. Again, you can see that we don't have it quite in the form that we need it to, so we're going to make some adjustment. The adjustment we're going to make is we're going to add 11x onto both sides of the equation so that we can get it over and be with all the other terms there. That's also going to help us out by making the equation equal to 0. So we have 2x squared plus 11x plus 14 equals 0. And again, we're going to, once we get to this point, we're going to try and factor it out. If you're up on your factoring methods, we would take the 2x squared and the 14, we'd multiply them together. We get 28x squared. At this point, I'll pause for a second and give you a chance to maybe jump in and factor this out yourself, since we're learning how to do that and we're getting real comfortable with it. Okay, so if you've got that factored out, again, we used 28x squared, and we wanted to find factors of 28x squared that would add, because we have a plus sign here, to give us 11x. Now, if we pay attention to our factors of 28x squared, we would be using 7x and 4x. So we're going to plug those in place of the 11x that was already there. So we've got 4x and 7x here in place of 11. And then we now have our four terms, so we're going to group. And out of our first group, we would take 2x, and that would leave us with x plus 2. Out of the second group, we're going to take a 7, because that's the biggest term that goes into 7x and 14. And when we pull that out, we're left with an x plus 2 as well. So now we have 2x times x plus 2 plus 7 times x plus 2. And we can break that down by taking out the x plus 2, and then that leaves us with 2x plus 7. And again, we're going to have that equal to 0, and we're going to apply the 0 principle, which means, again, we're going to take x plus 2 and set it equal to 0. Well, when x plus 2 equals 0, we can solve that pretty simply by subtracting 2 over, and we get x is equal to negative 2. The next one is going to take the 2x plus 7 and set it equal to 0. Now that's a little bit more complicated to solve, but we would subtract 7 over, and then we would divide by 2, and that's going to give us negative 7 halves. And I see that's going off the bottom of the screen there, but that's a negative 7 over 2. If you feel comfortable with it, or you're fractionally impaired, as we often joke, you can get a negative 3.5 would be the same thing. So our solutions are x is equal to negative 2 or negative 7 over 2, or negative 7 halves. Again, we've got two solutions. We see this is a quadratic equation, so that's what we're expecting, two solutions here. And I'll give you a second here to adjust it if you need to pause and get caught up. Okay, one more example. We're looking now at a quadratic function, and we are asked to find the zeros of that given function. Well, finding the zeros is basically finding the solutions. It's basically the same thing. We're going to use the same techniques. Finding the zeros of a function is basically the values for which that function is equal to 0. So we can take that f of x out and just replace it with a 0, and we've got 5x squared minus 35x equals 0. So basically all we're saying is we want to find the values of x that make this equal 0. Or, in other words, solve this quadratic equation. We know it's quadratic. It doesn't have the 3 terms because it's missing what we call a constant term, but it does have the x squared, and that means that it's a quadratic function. So we're going to factor this out. If you look back at your factoring techniques, the first thing we always check for is a GCF. And this one does have a greatest common factor, and in this case it is 5x. So we will take the 5x out, and we're left with x minus 7. So again, we have two factors, 5x and x minus 7. We're going to set both of these equal to 0 using the 0 principle. So 5x equals 0, which is a pretty easy solve. We would just divide by 5 there, and 0 divided by 5, of course, is 0. So we get x equals 0 there. Then we're going to take the other function, or the other factor, x minus 7, and set it equal to 0, and that would give us x is equal to 7. So this function has the zeros of 0 or 7. And simply put, that's that. I mean, it's the same way as solving a quadratic equation. And we just basically set the function equal to 0, and we find the zeros by solving it. Well, that's pretty much it for right now. I'm going to encourage you to take the practice problems in the packet that you've been given and work on those. And I'll talk to you soon.